Hey Technostuds, in this video we're going to talk about QoS strategies. There's a couple strategies that you need to know the difference between the two, and they're quite drastically different. So let's go over QoS strategies. The first thing that we're going to do is cover the three different strategies, and then we'll get more in depth into the three. The three are best effort, integrated services, or intserv, and then differentiated services, or DiffServ. Then we'll wrap everything up talking about a per hop behavior, or what PHB is. Here are the three strategies I just mentioned: the best effort, the DiffServ, and then the intserv. So these are the three strategies. Let's go over a quick overview of what each one of these are. First of all, best effort. Best effort is really not any kind of QoS strategy at all. You are just setting up the equipment and relying on the default settings. Well, really the default settings doesn't really do much for you. And so the quality of service, when you implement quality of service, it really has to be planned out very carefully, and it goes quite in depth, and you'll see that as we go through this module. So the best effort means that you really have not explicitly defined any kind of plan or went and configured anything on the devices. This can be very problematic if you have a lack of bandwidth. If you've got plenty of bandwidth and everything it has just lots of bandwidth to it, then this really is not that big of a problem. The quality of service comes in more to play when there is contention on the resources, when you have the delay points because your network is saturated or something's happening on your network. So obviously this is quick and easy to deploy because you're really not having much of a strategy at all. And once again, it only becomes problematic if there's contention or congestion on your network. Then we can go to the other extreme, which is intserv. And intserv is where you have an integrated service throughout your network and everything's talking back and forth. We'll take a look at what that looks like, but essentially it reserves a pathway for communication and guarantees once that connection is established that it's not going to drop any bandwidth. And so this is more difficult to implement because everything has to be integrated together, hence the name integrated service. So there are some problems with it. It does limit some scalability to it, but we'll talk about some of the pros and cons of that intserv. And then you have DiffServ, which is probably the more common that you'll see out there. And the equipment is configured so that it will label the traffic and classify the traffic and prioritize the traffic accordingly. This can be much more scalable and flexible, and it does not have the same guarantee as the intserv, but it also, that's one of the reasons why it's more scalable and can be more effective in some ways. There's really not too much more to say about best effort. Like I say, it's really just you're rolling it out with whatever is configured on the devices at the time, and a lot of devices really are not configured to do any sort of quality of service. They're just going to be whatever comes into it, then they'll send it out the other way. So that's best effort. Then we have that intserv, or integrated service. That's the other side of the spectrum when it comes to implementing quality of service. What it does is it's guaranteeing you that if you establish a connection, you will get the same quality throughout the connection, which sounds really awesome. It uses something called Resource Reservation Protocol, or RSVP. And what it will do is it will guarantee a connection from one device to another and reserve that bandwidth between these connections. It's kind of like with the old phone circuit systems, right? Where you're guaranteed this connection, it establishes a connection and guaranteed that connection. Now, the problem with this is it's very resource intensive. Once you can make this connection, no one else can use that bandwidth. Even if your connection, as long as your connection is up, then no one else can use that bandwidth across it, whether you're using it or not. So that's the disadvantage. So in some ways, this is like a step backwards when it comes to our more dynamic networks that we have nowadays. It doesn't allow us to be really dynamic. And it also creates quite a bit of setup because you have to make sure that resource reservation protocol is operating correctly to make sure that the guaranteed bandwidth is going, that you're going to get that guaranteed bandwidth. Then we have DiffServ, or differentiated service. Differentiated service means that ahead of time, you've planned out what is going to be your quality of service strategy. And what you're going to do is, somewhere in there, you're probably going to be doing some labeling, and then each of your devices, you'll go on here and you'll program each of these devices for your strategy. And what that means that is when a device is connecting from one location to another, each one of these devices is going to make its own determination about priority. It's going to base it off of whatever you programmed it for, so hopefully most of them are on the same page and are prioritizing the same type of packets, but it's not a guarantee that this device is going to be able to reach out to this device consistently. So that is the disadvantage with DiffServ, but this is more scalable because as you bring on other devices, you just make sure that they're programmed with the same set of rules as all of your other devices are. One thing that we will note here is this is called a per hop behavior, or a PHB. A PHB is because every single hop, per hop, 1, 2, 3, is going to make its own determination. So the behavior is going to be based off of whatever that hop is going to be, how it's programmed and how it determines the prioritization. So just know that per hop behavior just means that every single hop along the way is going to have to make a judgment call based off of the rules that you give each one of these devices. There you have it. There is the best effort where we don't really do much. There's not this global strategy of implementing QoS, which really equates to not much QoS strategy at all. Then we have the integrated service, which is once a connection is established, then you are guaranteed that amount of quality, that amount of connection between those two devices. And then you have something in between where we have the per hop behavior, where we've programmed each of the devices with similar sets of how they're going to prioritize traffic, but it still makes a determination. Every single hop along the way has to make a determination of how it's going to prioritize traffic.